Alright, here's a short little video explaining my process in solving question 5 in homework 4. I'll just go over this very briefly, kind of ignore all of the math details, the nitty gritty. We'll do a very first step, draw a very basic FBD. There's our pole. Let's make a color for that. There is a pole, and there is a force. There's full reactions here, and that force there, which will apply XYZ in some moment to it. And then, let's see, those are labeled. Leave this color, but I'm going to down the thickness a bit. B, this force is pointing at some point C here, which we are given. We're also given A, and B is at the origin. And then the value of this is 100 newtons. We'll draw out, this is of course a very rough FPD, it does not have everything it needs on it, but it's got enough that we'll be able to use it for the sake of the problem. Givens. I'm trying to avoid writing a ton just because it's very messy. Our givens are going to be this force. Our weight is negligible. I mean, it's not stated, so I don't think we can solve it if. And we're given positions of C and A. So C is at 304. A is at 5, 6, 1. Yeah, we have Z, X, Y. And then, of course, our moments and forces equal 0. Alright, so we're trying to find our reactions at B. And that is going to be 6 total reactions. You've got your Bx, Y, and Z, which will be our directional forces. We've also got moments, and we're just going to call these somewhat crudely MBx, MBy, and MBz. MBZ. That's legible-ish. First thing I'm going to do is set up an equation for the moments. We know that moments equals 0. That's equal to all our moments at B plus the moment exerted by this. I'm going to call this force Fc. And we're going to create a little vector notation for that as well, where it's 100 newtons times our vector, which is the directional vector. We can just subtract point C from point A or something like that. No, the other way around. Subtract point A from point C. So yeah, that's 2 minus 6, 3 over its length, which is 7. And that works out to a nice fractional number vector. 600 over 7, 300 over 7. Cool. We got that in form. We can cross that with our radius, BA. So if I'm not going to rewrite that again. So FC cross BA plus the sum of our moments at B, or the vector of our moments at B, equals 0. That's just vector plus vector equals 0. So the x components, y components, z components will all equal to 0. We get a system of, it's not even really a system, we just get 3 equations that will give us our MBx, MBy, MBz. So if we go here and just say equals, and then this cross product I've taken, but I do not wish to write out, so I will just You know what I'll do? Plus, oof. Or mbx plus negative equals 0. This one is 1700 over 7. That's a great 1700. And this one is positive 1800. And those are all trivial to solve. Then for our other forces, we'll set up a force relation. All sum of forces equals 0. This one's even simpler. All forces in all directions will sum to 0. So we just get our FC, which we found up here, vector form, plus B, which is our BX, BY, BZ. And that gives us the same similar looking set of equations down here, which is just bx plus minus, in this case, 200. And then by minus 600 over 7. bz plus 300 over 7. And those are also trivial to solve. So that will give us our 6 reactions at B. Reason this is entirely possible is because each of these vectors is itself just one unknown, right? So there's 2 ways to think about this problem, just looking at it. You can break it into your full x plane, y plane, and z plane. In each of those planes, there's 2 unknowns, which is the moment at B and the force at B. And you have your equations for sum of forces in that axis and the sum of moments in that axis. So 2 equations, 2 unknowns. And also each vector is an unknown, and in 3D space, you have the 3D full equation for the sum of the moments and the 3D full equation for the sum of the forces. So you also have 2 unknowns and 2 equations. But of course, if you keep the problem in 3D in full vector notation like this, then you've got, each vector is a collection of more unknowns, but that doesn't really matter, right? Because when you know the magnitude and direction, then you can figure out the components. Anyways, that's how I did problem 5 on this. Hope that's a good enough video.